Hello.
Hi.
How are you?
Hello.
Hello.
Hi, good to see everybody. So many people on the call. That's great.
Hello.
Cool. We're kicking it off today with shout out to Adam for becoming a database maintainer. Thank you for that, and congratulations. It's really great.
Yeah, thank you everyone for the help.
Congratulations, Adam.
Thanks.
Congratulations.
Cool. And you already have the next question. Would you like to take that away?
Yeah, so Ben, I think he's part of infrastructure. He asked about a specific feature called GitLab exporter. Is it in use or not? Because there are some failures and missing data on the charts. And yeah, I wasn't able to answer the question. Is this still needed, or can we maybe deprecate this feature?
I wasn't sure either when I saw that. I did find a dashboard in Grafana where we use it for pool mirrors. And I recall having a discussion a few months back about those metrics and that we should actually move them into GitLab maybe out of the exporter. And I'm not sure about the other queries in there. There is quite a few that are unrelated to pool mirrors. Has anybody else worked with those?
I have never seen this file.
So what should we do in this case? I mean, you mentioned that it's used in Grafana, but I guess that's not like a blocker to remove this feature. I don't know if it's useful at all to show this data, but I haven't. Yeah, I don't know, to be honest.
I suspect it could still be used for alerting, for example, for mirrors. So, but I'm not really familiar with that topic. Perhaps we can find somebody who knows more about the pool mirrors and how we use that in production, and make sure we still have that alerting in place, because if those metrics go away, then we probably don't have enough visibility into how the pool mirrors are doing. And we did have a discussion about that a few months back, where I think the went in a way that we should probably look into moving those metrics into the GitLab product, so that we can report those pool mirror metrics from it, rather than trying to run expensive database queries to figure out what the state is. We will basically push those metrics to Prometheus. But I'm not sure what the state of that is.
Yeah, do you remember if there was an issue maybe for this? I can link to or something like that.
I'll take a look later after the call to find that.
Thanks.
Okay, shall we move on to an interesting migration issue?
Okay. Hello, everyone. I wanted to ask for your advice. Since a couple of weeks, I'm struggling to fix the state of our database. I think I will share my screen and try to show a little bit of diagram to give them a little bit more context. So the case was that for some projects, we were missing the entries in the services tables, and these projects were the projects were missing those rows were the projects which were connected to the Kubernetes clusters somehow. The way that the project can be connected to the Kubernetes cluster is either through cluster projects, which is like, let's call it direct connection. So we have like one intermediate table between clusters table and the projects table, but also project can be connected to a cluster via its group. And in this case, we have another layer in between. So we have namespace, then cluster groups, then cluster. And also there's the case where project can access the instance, like the GitLab instance shared cluster. In that case, there's no, there aren't any connections between those two entries in the database. So we cannot detect if it by any query, except that this instance level cluster exists at all. And that means that all projects within that GitLab instance have access to this cluster. And the broken case was situation when on this shared cluster by any way or by group or instance, there was installed application. So there was the row in the cluster applications for misuse table. And our system haven't created corresponding row in the services table. The reason why this migration is challenging is that we have a vast amount of projects in on GitLab.com, but only around 6,000 of them were missing the entries in the services table. And to fix this case, we would need to perform complicated joins to make sure, especially for the group shared clusters. So we need to join projects with the groups, with the cluster groups, clusters, and in the end with the cluster applications to detect if there are missing rows, if the rows in services tables are missing or not. Yeah, so that's why it was challenging. And the first approach was because there was one attempt to write this migration, which unfortunately was reverted because it failed on staging. So the first approach was to detect all affected projects within the post-deployment migration and schedule the background job, which will update the service table to the sidekick. But the reason that this migration failed and was reverted was that for the GitLab.com, there is no instance level cluster which I mentioned, which means that only a small subset of projects has the access to the cluster. But for the staging.gitlab.com, there is the instance level cluster, and that causes all entries in the projects table to be affected. So we have like the two scenarios here. One with the group shared cluster, and this case most likely would be very sparse. So it's like, I don't know, 1/10 or 1/100th of the whole contents of the project table is affected. And for the instance, there's the whole projects table is affected by this case. And this can be this can cause the performance bottlenecks for the self-hosted instances, which we don't have any monitoring or any insights how this is happening. So that's how the context of this situation looks. We had a chat with Andreas right before this call, and he suggested some approach which looks really promising, because it also worked over the project stable, and it was even more sparse because it was like a only free affected rows as far as I remember, and it went through. I don't know if Andreas want to present this solution you used.
Sure. And thanks for
I will stop sharing the screen maybe for now and hop on if it's needed.
Yeah, perfect. Thanks for sharing the details here. I think this is an interesting case, and the more the larger our database is, the more important are those patterns, how we migrate data, or how we schedule those migrations. And I think what you already explained, the two patterns that we have today for background migrations is that you can either schedule jobs that basically work on a range of records. So you have a primary key range, and then one job tackles one batch. And the alternative is to schedule jobs where you are rather explicit about records that you want to tackle. So I think this, if I remember that correctly, this is what we had in the first attempt to. We would schedule jobs and for a number of individual project IDs, right?
Yes, exactly. It was the case, and it caused the outbreak on the staging because there's like hundreds of thousands of jobs scheduled, and the sidekick wasn't able to process them in any performant way.
Exactly, yeah. And even if we wouldn't have a problem with that. It might be different on self-hosted installations because their patterns could be different, and then you end up with a problem there, even if we don't notice it on GitLab.com. So those are, I think, a bit maybe risky in that regard, unless we can be really sure about how many records are affected. And I think the other problem that we saw here is with this approach is that you would basically have to figure out which records you want to touch, right? And this is where the migration failed, because this query was really, right? This query was also quite expensive, and it ran into a statement timeout first, if I remember that.
Yeah, it's like number of joins along the way, and some tables are quite big in numbers, so these joins are expensive.
Right. The case I linked, it was similar in a sense that there were only 3 projects on GitLab.com that were affected and that we wanted to fix, but basically running a query that would yield those 3 project IDs is not wasn't possible. It's not possible in the statement timeout. So instead of finding those 3 projects and then scheduling jobs for them, we were scheduling jobs to basically scan all the projects that we have in batches, and then run 1 query per batch to perform an upsert. And that was ultimately just affecting 3 projects, so creating 3 new records, and we had to scan all the projects. And that's also quite heavy, but it's something that works better than running an expensive query that is likely to run into a statement timeout first.
Yeah, I agree. So your suggestion is that we maybe could follow the pattern you used here, because in the worst or more pessimistic scenario, so with the instance level cluster, we will have to scan the whole project's table, and there will be inserts for each row, most likely. But still, this approach that you used allows us to insert those rows in batches. So it looks to me that it could handle. And if the if we have only the group clusters, the data would be more sparse, but also this even the query to detect the affected row is more requires more resources. If we will iterate over or scan through whole project tables, this detect query would be handled within the background job. So there is no hard timeout limit there, as far as I know. So
the timeout is still the same. So also in background migrations, you are typically limited to 15 seconds at the moment for statements. But I think the benefit that you get is that you're basically looking, or the improvement that you have is that you're looking at a specific range of projects, and
yeah.
I've seen or in a lot of cases this already helps, because you can use the primary key index, and then it's a narrow search compared to consuming all the table.
Okay. I think I'll try to implement or follow your implementation in this case. Thank you for your insights and guidance, because it was really challenging case for me. So thanks for help.
Sure, and thanks for bringing it here. I think it's really interesting case. Any other thoughts about it, or any other patterns that we could use for background migrations to approach cases like this?
From me, the other idea was to have like the intermediate or temporary table, where I would share the screen again. So we have the diagram. So my idea was to skip checking all the projects in the post-deployment migration, but only check this part. So pick up only the affected clusters without going for the projects, because the number of clusters is much smaller than the projects, and select only these clusters to this temporary table, and then iterate over this table and join the projects to records queried from that table. And the idea was that we'd like somehow split the task between the two queries. So one to create this table, and then we also could use this background migration pattern with the ID range, because it wasn't very suitable to this case when we tried to filter all the projects within the one query. But I think your approach is more straightforward, and we don't need to create another temporary objects within the database, which reduce the cost of this and work needed to complete it. So I think your approach is better.
Yeah, maybe we can start with that, and if it's still necessary, the temporary table is also helpful sometimes. Although just to be clear, we can't use a real temporary table. It would have to be a permanent table that we use for the background migration.
That my idea was that to create a table for like one release and then drop it.
Exactly.
That was what I had in mind. I considered the materialized view, but I'm not sure about self-hosted instances and which version of the Postgres SQL they are using. And as far as I know, the materialized view are from 9 point something up. So the older versions doesn't have this feature.
Yeah, no, we would basically use a normal table for that, I guess. Cool.
Okay.
Thanks.
Thanks.
Has anybody else thoughts on this, or should we move on? Cool. Then let's move on. If you could just stop the screen sharing and.
Yeah, I'm okay. Yeah, I got it.
Thanks.
Sorry.
No worries. Cool. So the next topic was a question about also a background migration where we could basically use a specific index that helps this migration. That's not used otherwise, but it is very targeted for this what we're doing here in the migration. I think that was the main question, if that is something we would want to do, or if there's any downsides to that, because we have to maintain the index until we can remove it, which is likely the next milestone. So we would be running a migration, and then we have the index lying around without it being used, and we have to maintain that. I think that's sort of the drawback from it, but I don't see any reason why we wouldn't want to do that if that really helps the background migration. I think it's a really good way of doing it. Do you have any other thoughts on it, or perhaps disagree with me?
I am not seeing how are we going to regenerate the ID, or that is not included on this MR.
Sorry, what was that about?
I think, yeah, I think we are talking about adding the ID column and then automatically backfilling these attributes, or not? Or I'm missing.
Oh, I think you're ahead.
Okay.
But that's the other question.
Okay.
Yeah, but let's go for that. Unless there is more comments. So this is the topic is how do we have a table that doesn't have a primary key? How do you safely add it afterwards? Because now you need it. Adam, I saw you put comments on that. Would you like to summarize those?
Yeah. So I'm not sure about the size of the table, but normally you can just add a serialized column to the table, and that will pre-fill the existing records with auto-incrementing primary key, and then you can just set the column as this is my primary key. And I guess Crass problem was that this when you add a serial column with the whole table is basically rewritten because it has to pre-fill the serial column with the incrementing IDs. And I guess he was looking for a simpler, a more safer way to actually do it. And maybe we can do the incrementing the ID in via batch updates, and then just apply a sequence on that column, and that basically makes it a serial column, right? Because you have the sequence auto-incrementing, and then we add it as a primary key. So basically, we do the increments via a background migration. But it really depends, I guess, on the table size. Maybe adding a serial is straightforward if the table has only a few hundred rows.
Yeah, so for a small table, you would just add a column with a default going to the sequence, and that sort of already fills the table up and also increments the sequence. What I wasn't sure for larger tables is so we would add the column, we would have a background migration, batch updating, or incrementing values in there, and then ultimately we can use a unique index to add that. If there is no incoming traffic at that time, that's straightforward, because you run that job once and then you can be sure that there is unique values. But if there is traffic coming in at the same time, I think at some point you have to have a point in time where you basically stop that traffic and make sure that the sequence or make sure that the table is totally pre-filled, where that all those records have a value, and then make sure that the sequence goes on top of that. So the sequence has a state as well, right? It increments values, and thereby it has a state. And I think at some point in time you have to say like, I'm now reconfiguring the sequence to start from a higher point. So otherwise, you have clashes, right?
Yeah, and I think if the background migration can get the sequence done, let's say 99.9%, and then we say, hey, let's log the table for updates, and then we find all the records that have been inserted, while what we missed, basically, just to check if we actually missed updating the ID for those records. We make that within the lock and then apply the unique index plus setting the primary key. Then I would say we are pretty fine because, yeah, I mean, I can imagine a concurrent scenario when we simply just miss adding this new value to specific records. Well, there is actually a nice feature in Postgres. So if you have a unique index, then you can actually add the private key constraint to the table by specifying the index name. So I wouldn't expect that Postgres will recheck the table from scratch, right? To ensure the uniqueness, it will trust the unique index to actually tell that, hey, this is actually unique. Just add the primary key constraint.
Yeah, I think so as well. This is the cheap step in the end, basically. But it boils down to how do you generate a unique sequence for a table with existing records while new records are coming in. Perhaps if you, sorry, go ahead.
And what are some reasons we are against, for example, UUID primary keys? I mean, which could make this easy, but I think for some other reasons, you wouldn't want them in Rails context, especially.
UUID is supported by Rails, so that should work. I don't know why we don't use them. One reason could be because of the size of it.
Yeah, there are many reasons. Just for that particular case, it could be interesting to think about it. I'm not suggesting it, just brainstorming. But fine, Adam, your approach is more or less, I think, what we do always with concurrency situations.
UUID is interesting. There are different types of UUIDs as well, right? You can have a random UUID, a completely random one, or even base that on some input values. How would you generate the UUID in this case? Do you just use a random value?
First, I didn't check. I don't know if Postgres could have a way to generate them easily. I don't think that's a lot, actually. Finally, I think our problem is not ensuring uniqueness, and because sequentiality, I mean, we can skip ahead and we can have a sparse sequential range. I mean, if anyone worked on the Microsoft SQL world, they usually work with UUIDs, and I had worked a lot, so that's a different story. I don't suggest it. Particularly in that case, would it have any value while generating? I don't think so at the end, especially in a busy, large table. Unless Postgres has some internal support for default creating the UUIDs for you, which never comes free in the,
I've seen an extension for Postgres that basically exposes a UUID function. So you can actually make the default value as a UUID. So it's like automatically provided by Postgres when you insert a new record.
I still wonder a bit what type of UUIDs we'd be using for a primary key. Because the completely random one probably works. Is that maybe a good way of saying it? But the other ones, I think they all need some input. So you can generate some UUID given an existing value, but it's only going to be unique if the existing value is unique as well, right? It's probably the random UUID, isn't it?
Yeah, I had used UUIDs in Postgres previously. And yeah, we always use the v4, which is the random one. But there is an extension that supports it. And Postgres also has a specific data type for UUID, which is like a packed representation. So it's not as large as a text value or something of the string representation. So it's not that big. And of course, the advantage kind of, which was mentioned earlier, is that you can generate that in the app, not necessarily in the database.
And I think the smallest universally unique ID is more or less 128 bits or more. So that's the cost finally when we have begin for 64 bits, I think.
You can see a problem with UUID using our utilities. So we have lots of functions for iteration because we usually rely on the ID, like this each batch thing. And also the sorting. We often don't use the timestamps to sort by created at, but we just sort by ID. And I guess UUID, that is the default one before. I don't think it has this capability to be actually somewhat sortable. I don't know.
Yeah, I think it will also kill batch counters.
It's a good point. You can probably still reason about, or that there is still an integer representation of UUIDs, so you can still sort them, but it's not that they have a relationship with when the record was created, like the ID sequence has, right? There's a strong relationship between ID sequence and the created at time. Cool. Yeah, curious to see how we solve that. Ben, you have an update from last week.
Fairly quick one. It's just we touched on it at the end. Customer tripped over the problem that AWS doesn't run analyze automatically when you do an upgrade on RDS. So thanks to Balu and the distribution team, I've finished piecing together how it works in Omnibus. So we run that at the end of an upgrade.
No, that makes a lot of sense. I think if you miss that step, then you're in real trouble because the statistics are completely missing. That's good to know. And we should also keep that in mind for the upgrade on GitLab.com, but I'm sure we do that. Cool. Well, thanks for updating from last week. The last point on the agenda, I just added that. I found that really interesting. There's an interesting discussion going on, started yesterday, about basically frequency of database changes and how we test database changes, and yeah, in general, an interesting discussion. Adam, I saw you added a few points there. Would you like to say?
Yeah. Just I don't want to really go into the details, but our problem is that we look at the database migrations. We kind of try to think about past historical, scenarios, and then how problem happened like historically, and try to say, yeah, this happened in the past, so don't do this, but find another way to do that. For example, when we do database migrations on high traffic tables, and we basically don't run the migrations on a production size database before actually hitting Canary, as far as I know. And yeah, that would be a nice step forward. But I think that's not enough. We should also find a way to simulate like a real life scenario, because when the migration runs in production, it's not just the migration, but we also get a lot of traffic from the application side. And without that, like really special locking scenarios, we might not be able to detect. And it's often that the migration succeeds, but actually the background migrations have their issues. Let's say they are too frequent, or they are just basically processing too much data and might affect the performance of the production system. So it's really difficult to have something that developers can actually use without also exposing customer data, and actually it kind of mimics the real world scenario. And yeah, it's a big challenge, and I'm curious how we will solve this. And I also understand the idea to limit the changes. Totally understand, but probably it's not that simple to solve this problem, right? Because yeah, it's not, the problem is not the amount of changes, but what kind of changes we are introducing, right?
Yeah, I really agree here. I think you can have two changes, and they also blow up in production. So it's not really about. I think it's not really about the number of changes that we're making. I wanted to add that I think we also don't have a canary environment for staging at the moment. So basically the deploy and how we run the migrations and staging is a bit different than in production. So I think we in staging we just we run the migrations and then we run the test suite basically on the installation. But in production we have like actually two different code versions running when we for a while until we deploy, right? So it's quite a bit of difference to production, and also the size and staging is very much different. I caught that recently. I thought it was around 1.5 terabytes, but today it's only 400 gigabytes anymore. I'm not sure why that is. Maybe we did some maintenance also, but it's so much smaller than production. So not even that is a good environment to test that anymore.
Is the statement timeout on staging also different? I don't remember. Is it also like 15 seconds?
I think it is, but I'm not sure.
Was it a little bit lower? I think we changed it, right?
We had a discussion about this. I remember that as well.
Yeah, I think it was lower because the traffic is also lower. So, but I don't recall. I think there is an issue about it.
Mm-hmm. I remember Nikolai also mentioning that we could have ways to test migrations with database labs, and Joe, what he's working on. This is, I think that would be really helpful to be able to have your migrations, grab your migrations and run them on a production size database and database labs. I wasn't sure how background migrations would work there, but just having the normal migrations is already a good step. Probably a background migration that takes a few days on GitLab.com takes a very long time in database labs to execute fully. But perhaps just grabbing one job from the background migration and execute that is already insightful in some ways.
Yeah, we could extrapolate the effort required for by the size.
Yeah, that would be cool. And you get some feedback from database labs, how long it takes. Although probably runtimes on database labs are always like quite a bit different from the production runtimes. And we also don't have any traffic on those instances. Adam, you mentioned in that scenario that you had a way to simulate traffic, or so that you're.
Yeah.
How does that work?
So the idea was to, so it's not directly on top of the database, but basically having clients that are doing various web requests to the application. And that basically generates similar load that the production system is actually getting. So that was the idea. But to properly test, we should have a similar configuration, a similar setup than the production system. And we used a tool called JMeter. We had a tons of custom, like it's basically we call it client, that are just sending requests to the server and of course doing some sampling and measuring the response times and collecting stats. And of course, monitoring on top of the production system that we are currently testing, production-like system, so we can actually compare the performance characteristics to actual real-world data. And that's how we could match that, hey, the system what we have here is really close to what we have on production.
Yeah, that would be very nice to have. There's also PG replay. I found that interesting because you can basically record your traffic and then you can replay that into any environment. And I think it also allows to directly compare the the execution times. We tried that once on GitLab.com, so we wanted to capture some traffic, and that means you have to crank up the log volume because you basically want to log all the queries that are coming in, and that didn't work at that time because the volume was so large and rather unmanageable. I think we managed to record 30 seconds of traffic before it crashed.
So our idea was to test it from the outside, so we can basically catch other issues than database performance issues. For example, one developer used the wrong log level, and after 10 minutes, the disk was full under normal load. And these like infrastructure specific issues would be also revealed.
Yeah, absolutely. I think we're rather blind in that regard today with any of the changes that we make. We don't have any way of testing them with actual traffic at the same time. And staging is not a solution for this at the moment.
Do I understand the discussion correctly that Yorick suggests to limit how we code, how many migrations we do, and we test it? However, we discuss here how we test migrations better. So we don't agree that we should limit adding migrations, right? I mean, when I read discussion, usually you focus on how to better test migrations in a production-like environment in all the comments. But Yorick's original idea is to limit them and maybe have few of them, if I'm not mistaken.
Yeah, I understand it in the same way. I'm just not sure what the benefit is from limiting the number of migrations, because I don't know, from the last incident, if you pick the 1 or 2 migrations that were causing it, then if we only had those, then we would still have the incident. So I'm not sure about that.
Yeah. I mean, I went there to write about iteration value, but Yorick wrote about it himself. So 2 risks there is that if we limit the migrations, we, as usual with the iteration, non-iteration risk, we shall increase the number of migration, and that will be a nuclear risk, you know, at some point, a Big Bang risk. And secondly, if we now in the MRs tell people not to do a lot of migrations, they will go beyond good relational database design, and they will try to fit their application into existing columns and, you know, abuse or reuse existing tables in different ways, which is going to have a bad database schema design effect, like single table inheritance, polymorphic designs, having full JSON fields, and even document-centric columns. So I think, and finally, I think that in the testing step, if we could have the minimum production-like migration up and down runner, that could be, I think, solve some of the issues. In my previous web application, we used to keep a, you know, a slimmed down production-like environment copy of the database, carefully maintained, and we were using it as a, you know, migration replayer for up and down testing, which is similar to what you were talking about.
I think part of that conversation also goes about, like you already explained, about quality of the modeling, or you know, making sure that we follow sane relational modeling instead of just adding columns to tables. We discussed it last time here as well. I think I think that is a concern that we should have, that we are sometimes we're adding migrations just to ship a feature. We're adding columns to tables just to ship the feature, but we're not really, perhaps we're not having enough discussion about how is this going to look long term. What's in 3 months? Are we going to have like 10 more columns to this table, or is it like really that we should break apart the table already? And that means a bit of more work upfront, because you have to create relationships or a lot more tables. And that's a bit more effort to compared to just adding a column. But down the road we will have less expensive changes, because then we add those columns to the existing small table. And as far as I understand this, there is also one of the concerns is also that we run very expensive migrations because of us not maybe thinking ahead a little bit, so that we have to shuffle around a lot of data in production environments. Maybe we can get better at that.
Yeah, part of the Rails magic, it makes very easy for any developer to create migrations models, and that's also a problem then for the database. I mean, Rails enables any, even any developer to make migrations very easily. That ends up also being a curse, in that we end up having a lot of, you know, differently designed tables, index columns, logic.
Yeah, I think that's what we're here for as well, partly to discuss those and make sure that we have a more consistent modeling, more consistent migrations rate.
Yeah, I think in part it's also about being mindful when it comes to adding migrations or modifying our schema, and particularly on large tables. Like from the incident, it was just renaming a column, and it caused on services, which is an old table, and it caused like a disaster. And yeah, I think we just need to be more careful when reviewing MRs.
Could we have noticed that that issue before?
No, I actually reviewed that MR, and I didn't notice, like, even on the incident call, everyone were like scratching their heads because this problem was very tricky. But perhaps analyzing the problem, they wanted to change a column just because instance was a better name. And perhaps that makes sense on the backend code, but perhaps the column wasn't necessarily needed to be changed. Like services is a huge table, renaming, perhaps it is not necessary. Perhaps we just need to add an alias on the model and just go with it. That could have avoided the incident.
Mm-hmm. So balancing out the risk with the benefit from doing that. Yeah. Yeah, I think it's hard to catch. If I see a column rename, I think that's totally fine. From you know, we have a helper for it, and that typically works just fine. But yeah, keeping the risk benefit ratio in mind is a really good point. Cool. Well, I'll follow that discussion. I find it very interesting. If you want to comment on that, please just follow the issue. We're also at the top of the hour nearly. I just wanted to throw in another issue that came out of that discussion that I was really surprised of. I've never heard of that before. That is that, you know, Postgres has a column limit, which is not really too surprising. So you can only have, I think, 1,600 columns in a table, and we shouldn't have those white tables. So that's not the problem. But what I found really surprising, what I didn't know, was that any columns that you drop, they also count towards that limit. So if you have a table and you keep adding and dropping columns, you may even reach that limit, even if your table has like only 10 columns. That still exists. Yeah, there was a concern how that looks like for GitLab.com. I ran a quick query to figure that out. It's not that bad. But if you look, for example, at users, that has 49 columns in total, which is really large, really wide. And 10 of those have been dropped, and 34 dropped columns for application settings. So it's not that bad. It's not that we're hitting that wall, but it's kind of interesting to see. And it's also there. I think there's no easy fix we found for that. So at first I expected a vacuum full table rewrite or anything like that to fix the problem, but it doesn't. So the only option that you have is really to recreate the table and copy all the data over to drop those columns, unless I'm missing something. But it's kind of surprising for me.
So we don't have much risk from drop tables at this rate, no? Like in 5 years or so.
From drop columns.
Yeah, dropped columns and total.
Yeah, so the number of dropped columns that we see in the statistics, this is what we accumulated since GitLab.com started, I guess.
Just a question. Do you know the design of application settings? Not that I mean something, but why was it decided to put every setting in a one row and in each column rather than having a key value, application settings table where keys were the setting names and the column, and we had a value column. And do you remember? Does anyone know why it's better, worse, or something? Or maybe next time. Okay.
No, I don't remember why we started doing that. I think it's been like that for quite a while, and we just keep adding columns to it.
Would it make sense to migrate it to rows?
I think we don't, as we discussed earlier, if we don't want to take any risks, there's no reason to touch. But I think in 2 years or so, that's going to be the quickest growing table in column.
It does feel like an empty pattern, doesn't it? I mean, it has only one record, but it could look like much nicer. At least if you look at the ERD, it looks really ugly. Like there's this one large table. I don't know if we have reason today to migrate that though. Do we have an issue for that by chance to discuss the design?
For application settings?
Mm-hmm.
I don't know any. It's just in nearly all my other projects, it was designed in a row based, not that and that was surprising. I thought maybe it solves some other issues, like having a quick form on Rails in the admin area.
Yeah, perhaps we can create an issue, and I'm sure there are many informed opinions about that, better informed than I am. Cool. Well, we're at the end of the hour. Thanks everybody for joining the call. It was really good today. And have a nice day and see you soon.